Welcome back to our number systems series. This episode is all about hexadecimal to decimal and how we convert from hex to decimal or denary. So, like the previous method from denary to hex, if you've got good mental maths, well, you can just write out the base 16 columns. Remember how these work? I know I keep saying this, but it's how I get you to learn this. You start with your number system on the right hand column, and that's to the power of 0. So in this case, base 16 hexadecimal is 16 to the power of 0. That's the ones. Then go to the next order up, which is 0 to the 1. So that's 16 to the power of 1, which is 16. Or if you imagine you're in binary, it'd be 2 to the power of 1. Go up again, it's 16 to the power of 2, which are 256s, and 16 to the power of 3, 4096. So if you wanted to convert hexadecimal number 66BC, put it into the columns in the right order, 66BC. And now, remember, how did you do this when you did binary? You'd put your binary numbers in here, and then you'd multiply out. Or your denary numbers, you'd put your denary digits in the right columns, and then multiply out. It's no different here. So it's going to be 6 times 4096, plus 6 times 256, plus B times 16, plus C times 1. So you're multiplying out the columns. Well, let's go and do that then, okay? 6 times 4096 is 24,576. In the exam, I'm sure you could probably do that just by writing out however you normally do your multiplications, maybe 4,100 multiplied by 6 and then taking away 6 times 4. But there you go, that's 6 times 4096, then it's 6 times 256, which is 1536. Now, B is 11. So that's 11 times 16, and C is 12, so that's 12 times 1. Then you'd have to add all of that up together to get you 26,300. So you see what I mean here when you've got to have good mental maths for this one. But me, I think that's a stretch too far. That's going to slow you down quite a lot. So use the method where you go from hex to binary, from binary, denary. That's going to be a less maths intensive way. So let's look at an example here of 7C. First, convert that to binary. So remember what you're going to do? You group each digit individually. So you're going to have 7 and then C. Remember, C is 12. So C is 12, which is 1100. Remember how your binary columns work? Your first column, your right-hand column, is the 1s, then the 2s, then the 4s, and then the 8. So 8 plus 4 is 12, which is what you've got. 7, there's the 1s, 2s, 4s, 8s. 1 plus 2 plus 4, 7. Now you have to push those together. 0, 1, 1, 1, which is here. 0, 1, 1, 1, and then 1, 1, 0, 0. 1, 1, 0, 0. Number your binary columns as normal. 1, 2, and just keep doubling. 4, 8, 16, 32, 64, 128. And then just add them up. You've got 164 plus 132 plus 116 plus 18 plus 14. No 2s, no 1s. That gets you 124. Get you to try it. Which way you're going to do it? Quite simple for the first two. What you'd normally do, write out your hexadecimal columns, write the digits in the right columns, then multiply them all out to get denary, or convert them, first of all, from hex to binary, which is put them in groups of 4 by each individual digits. And by the way, we've only ever normally used two digits for base 16 hexadecimal. Because in an exam, that's normally all you see. But there's no reason why you couldn't put that D as a group of 4, that A as a group of 4, and that B as a group of 4. Only problem is, I've not told you how to get beyond 128 through past 8 bits. But if you know how to double, 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 and double, there's your next 4 columns. But you might want to just write those out in the hexadecimal columns. Have a go, and we'll go through the answers in a minute. Pause the video. Okay, welcome back. Well, 8. 8 is just 8. It's right there. Hex 8 is denary 8. Easy enough. And look, B. Hex B is denary 11, so there's no real difficulty there. Here's the real difficulty in the next one, BAD. So, put that in the columns. That is D1s, A16s, and B256s. What's B? 11, so that's 11 times 256, plus A, which is 10, 10 times 16, plus D, which is 13 times 1. So add those all up together, and you'll get 2989. I think you know what's coming next, which is you to go to Edmodo, go to the number systems quiz called Hex to Denary. Have a go at those. Remember, it's part of your gradebook. If I don't like your result, I'm going to delete it and ask you to do it again. Any problems, you know how to get in contact with me. So, recap of this lesson, and actually recapping of the main part here. It was all to do with the last 2 episodes were hexadecimal. In fact, I think it's not actually the last 2 episodes. It was the last 1, 2, 3, 4 episodes were all about hexadecimal and how you go from binary to hexadecimal, hexadecimal to binary, denary to hexadecimal, hexadecimal to denary. Always going to be a question in the GCSE about that. So you should now be at a stage where you can tell us what digital and analog is. Tell us why computers store things as binary. Describe the 3 main number bases we use in computer science, base 10, base 2, and base 16. You should be able to represent whole numbers in hexadecimal and binary. And you should be able to convert between binary, hexadecimal, and denary, and any combination of those 3. The key question was, why is DAD 3501? Well, hopefully now you're at that stage, you do know that. Is that the D, which is 13, is 13 times 1. So let's put in the columns here. So DAD, so D is 13, that's the 13 ones, then A is 10 16s, and then D is 13 256s. Add those all up, you get 3501. That's why DAD hexadecimal is 3501 in denary. Next episode we'll be talking about addition, binary addition, and then we'll do binary shifts, and then you're done for the number systems.